This is the 25th video presentation for the Case Plant course. As you view this video, make notes of important information. Pause, repeat, and resume the video whenever necessary. Water loss, Lesson 6.2, All Wet. You have completed Lesson 6.1, Plant Food, where you discuss nutrient needs and interactions. Nutrients are affected by water in the plant. This presentation provides the background knowledge needed to complete the activities for Lesson 6.2, All Wet, and introduces important concepts and terminology for water requirements in plant production. Water is used by plants for 4 specific processes: translocation, transpiration, photosynthesis, and osmotic pressure, or turgor, will be discussed in depth momentarily. Translocation is the process by which water and dissolved nutrients are transported through the plant by the vascular tissues. Transpiration is the process by which gas exchange occurs for photosynthesis. Water vapor is also released through the stoma during transpiration. Refer back to Lesson 4.4, Leave It to Leaves, for more information about leaf parts and function. Transpiration rates are affected by temperature, wind, and humidity in the growing environment. Activity 6.2.2, Translocation and Transpiration, will examine these environmental conditions in more detail. Water is critical for photosynthesis. You will need to know the inputs and products of photosynthesis shown here. More about photosynthesis will be discussed in a later lesson. Plants require water to maintain turgor and prevent wilting. Turgor is measured in osmotic pressure. Refer back to Lesson 4.2, the radical root, regarding turgor in plants. Water is lost by the growing environment in 3 ways: evaporation, transpiration, and runoff. Evaporation refers to water lost to the atmosphere as a result of heating up to vaporization. Transpiration refers to water exiting plant leaves through the stoma. Runoff is a major problem for automated water systems. Overwatering causes runoff and could also lead to erosion problems. Too little water results in stress for the plant. This may be manifested in different forms, including wilting, decreased photosynthetic rates, tissue damage, and stunted growth. Water stress is measured in stages. Prolonged periods of exposure to stages 2 and 3 can cause permanent damage to a plant. Some greenhouse producers touch the potting soil with their fingers or detect the weight difference of the container to determine when to water. This takes practice of growing plants before you can rely on these methods. Crop producers will use field sensors or infrared satellite pictures to determine crop water needs. The most practical way for small producers and home gardeners is to use a simple moisture meter. It is important to water only when needed in order to prevent waste of water and to prevent overwatering plants. If you wait too long to water, detrimental effects will result to plant growth. Too much water can be just as harmful as too little water. Nutrient leaching, root hair death, and soil erosion can result. In Lesson 4.2, the radical root, you learned about harmful effects of too much water. Most plant producers rely on rainfall, irrigation, or a combination of both water applications. Rainfall can fluctuate. In some areas, rainfall alone does not provide enough water for a crop to mature. Under a structure such as a greenhouse, producers must provide water through artificial means. Irrigation will be discussed further in Lesson 9.1, Tools of Plant Production. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. Keep any notes you have from this presentation organized and available for use throughout the course. Through Activity 621, The Biggest Loser, you will determine the rate of transpiration and evaporation for different plant containers. This will help you to understand how water loss can be managed in growing environments. Your teacher will provide instructions for setting up the experiment.